Hello guys, welcome, and in this video I want to quickly run through the features that I've built in the project I'm currently working on. So let's run it. So I have a couple of debug panels which you can enable using F1, F2, F3 keys. So here you can select the unit, here you can select the player, you can drag them, then you can do the same thing for another player and drag the units, then you can save it, like whatever, save it, then you can play this bell in the real time. Wait, you need to start it, and you can see how the units start moving, attacking, and all of that. I didn't bother too much with the graphics, but I made simple animations and health bar so that it is just clear what's going on here. And yeah, it is funny, it is actually a draw, but yeah, you can simulate it once again, then you can select another template, you can execute that template as well, and basically, and yeah, you can also control faster or slower, and you can also pause the bell. So now I want to go a little bit into the technical details. So the first thing is that I have some debug tools. For example, when I enable the debugging and let me execute the next decision, what you see is that those are tiles that the unit is currently on. Those tiles is where they are moving. Then you can see the rays of the target, of the current target, and you can also enable the using F4 the panel to display like every single simulation, and you can run it, and it can provide you valuable information of what is going on here. So what else? Also, I can show you the AI. So I did build a custom graph for it. Shouldn't be here, but anyway. So I can open it, and you can see I have this decision tree. So I've selected the decision tree AI because the first reason, it is performant. I need performance. Then it separates concerns of making a decision and then behavior itself. Here you can see I have some decisions that I can select, some actions, and I can compose them in various ways. I can create a new one, bind them, and like that. So here I also have this decision tree saver, and it allows me to save all that decision tree and then move that into the server so that it can build it from this data. And it also supports versioning. It means that when I rename action, add it, remove it, it doesn't matter. So I have an enum which tracks the current decision. So as long as you don't change this enum number, everything should be fine. And the next thing I want to discuss, I think it is the architecture that I have. So I'm using the model view adapter, which is a variation of model view controller, but in the model view adapter you have model and view completely separated from each other. They don't depend on each other, they're completely decoupled, and it means that I can move the model to the server since it doesn't couples to anything, and I can change the view independently of the model, which is also a good thing. And I also have a layer setup. So in the scripts, let me make it a little bit bigger. So you can see I have a couple of layers. It is controller, it is a infrastructure, model, and view. So model view controller, like it should be adapter, but whatever. And you can see that controller depends on model, view, and then if I show you the model, you can see that it doesn't depend on anything. The other good thing is that I toggle the no engine reference so that it doesn't reference like anything, and also I override references so that I don't have unnecessary libraries, and I do the same thing for the libraries used by the model so that you can see that I'm using only the necessary bits. So it is just good, and when I will move to the server, it will just work. Shared and shared glide, I think it is pretty self-explanatory. So shared is on the client and shared is between everybody. And I have this infrastructure layer. So this one is used to set up basically everything. And I think let's move to the most interesting part, which is a code. So here you can see the composition root. I'm using dependency injection, and it provides a lot of benefits so that it moves the responsibility of creating objects, composing objects, and controlling their lifetime from those objects, so that it is a good thing. It is also a lot of flexibility because here you can compose them in any way you want. And let me quickly just close those. So here you can see I have a bunch of different regions, and they are not used only just to hide things, but they also indicate the dependency flow, if I can say so. So for example, all of those stuff, they don't depend on anything. Remember then, the view and the model are completely unaware of everything, so those things don't depend on anything. And then I have this controllers, and I have a bunch of them, so I just split them by feature. And let me show you what happens here. So here I have some controllers, UI, view. Then here I load the config of my units. I set up some infrastructure things which are generic and don't depend on anything. I have view which is created here, the same thing for the model. And then I have the controllers. So I have, and I have a bunch of controllers here. And what happens here, I create objects, I compose them. Then here I actually, wait, I didn't mention that. Yes, as you can see, I'm using the pure dependency injection. It has some benefits and some advantages. In my case, it is good. It also can display you some design flows that you may have. For example, it detects cyclic reference. You just cannot build an object that depends on other objects and use that object in that other object. So another thing is, it is very simple. You don't need to understand the container API or whatever, and it is static, so that if you don't supply some dependency, it just won't compile. So yeah, it has disadvantages because each time you modify, you need to go there and change it. And also, if the team consists of multiple people, they all modify the same file, so merge conflicts there. So but yeah, I think I will refactor that into the move that to the container based approach one once I hit like 1,000 light, I guess. I don't know. Yeah, I can go like really deep into that anyway. So what I do here you can see I init some observables, I init some UI, and then you can see that here I am subscribing to UI. So we are slowly moving to the reactive programming that I have here. So you can see that controllers subscribe to various things. They add themselves to the disposable, and on destroy I just release clear everything so that I don't have any memory leak, and it is a good thing to have. And I guess since we're here, let me show you some. So for example, in this class, let me show you the reactive stuff that I have here. So for example, look at that. So the benefits is that I can handle asynchronous tasks in a composable way. So you can see I have some composable operators, and you can see how clear it is to read that, right? So it is a powerful way to code. I think the next thing I want to do is to go through a couple of patterns that I have here. So let's start, I guess, with decision tree node, which is kind of a composite pattern. I think it will be more clear if I'll show you them. So that one is what I'm using to construct in my decision tree graph. So it is the information about decisions and actions in my decision tree. So it is kind of composite because here in the action it uses this type, but then decision it uses also two components. So it is kind of composite pattern here. And to compose the decision tree, you can see that I'm using another pattern, which is a visitor. So let me show you that. So here you can see that the power of visitor is that it uses double dispatch, so it knows the type of the thing, and so it knows where it is a decision and when it is an action, and it can handle them in a very nice way. It is encapsulated. So here you can see that I initialized. Also, I'm creating that in the runtime, and I certainly don't want to do that each time I create the decision. So for example, on the server, I don't want to do that, and so for that I'm using another pattern, which is prototype. So it is performance pattern, and I can show you some implementation. So it basically creates a new one and copies the things here. So it just makes it a more performant way. And let me show you where I'm using that. So in the decision factory, another pattern. So here you can see that I create this decision tree, and then if I don't have it, and then I clone it so that it is very performant. I should probably not do that if I create it for the first time, but it doesn't matter. Anyway, also I saw that, yeah, I have this login decorator, which is another pattern which wraps decision tree node. So, and what it does when the decision makes, when I make the decision, I basically log some stuff here. And yeah, you can see that you can use patterns like together. They kind of work together very well. Then I have this I comment, which is a command, so I have a couple of those, and the purpose of them is because I want to execute this command in the future. So for that I'm using that, and it does its job very well. What other patterns I'm using? I think so. I didn't finish with observable, so I'm using the observable from the UniRx. Then I'm using the even bus, which is, I get it from some library, but it doesn't matter. I need to replace it. It's really bad, but the nice property is it is like observable, observer decorator kind of, observable mediator kind of pattern. So it completely decouples the model and view and allows them to communicate without coupling each other. So you can see here I'm registering some events to the controllers, and then those controllers just handle them and display on the view wherever they need to display. And also I'm using that in the health component. I'm using another observable pattern here. So it is a more classic one. So you can see I have the list of things. I subscribe to something, and when the unit dies, I notify the observers. So also the health component. So I'm using, let me show you the unit. So you can see it is like component pattern, and the unit has a bunch of components, and each of them single responsibility does one thing, but does it well. And yeah, I think I have another pattern here, right? I have this finite state machine, which encapsulates logic of transitioning the state. And here I have the state pattern, which is very simple. It just handles the transitions in the Unity animator. So very simple stuff. And I guess I can show you chord changed. I had something here. Alright, so I have this kind of strategy thing. So when the unit changes the coordinate, for example, if I drag the unit, it needs to do different stuff depending on whether it is a model or the view. So on the model, I set up the starting coordinates so that when the bell starts, it is in the right spot. And if I show you the unit view, you can see, so I'm I need to snap the unit to the tile, so I'm doing exactly that. And then I can show you where I'm constructing that. So it is here. You can see I'm using that in both the player and so it is basically a singleton lifetime, so it is a good thing. And here you can see I create another strategy, why it is called strategy anyway. So you can see it is a behavior, so let me show you. It is located in the shared library, so that it is shared between unit view, between the view and the model. So they basically move the stuff the same way, but they have different strategy for handling the unit coordinate changed. So yeah, you can see how those objects are composing very nicely. And I think it is pretty much it. Maybe I forgot a couple, but yeah, I think that's it. So thank you guys for watching and have a nice day.